All right, so for our next example here, we want to find all the points that are horizontal to this graph. Now, we've talked about this before. Anytime they mention the word points, they say you need x and y. And we even talk about horizontal, talked about where the slope is 0. Now, we're going to get a little bit more nerdy with it. We used to say m equals 0, but now we want to start being in the correct notation. dy dx is 0, or the slope is 0. And this is the graph of this relationship right here. So we're looking for the slope as horizontal. So it looks like we have two places where we have a horizontal tangent. And even right here, look, we even have a vertical tangent. The nice thing about implicit derivatives, we can actually find vertical tangents too. You're going to see one like that on your homework tomorrow. And maybe even tonight. We'll talk about that today. We'll see. You'll see one like that. Now, so we want to take the derivative of this function right here. I'm going to zoom in here real quick. So when I start taking the derivative, the x's just remains the same. That becomes 6x squared. It's the y's that are new rule. Remember, the derivative of y is dy dx. And we get that from our chain rule. So when I take the derivative, I'm going to drop my power like it's hot, 2y, but then I got to multiply by the derivative of y, dy dx, and that's going to equal 0. That's the derivative of 3. Now, I'll tell you a secret. Nobody ever remembers, oh, it's chain rule, Mr. Warnell. Nobody ever remembers that. What they do remember is anytime we take the derivative of anything with a y, you tack on that dy dx. Piece of cake. So I'm going to go ahead and find my derivative, dy dx. That's going to equal, I can solve for it here, negative 6x squared over 2y. So there's my derivative. Now, we are not done yet because they wanted us to find out where the slope is horizontal. And you're going to have, so let's do some really cool stuff. This is cool. You want to write this down. Cool stuff. Okay? Let's think about horizontal lines. If you have a line that's horizontal, what is the change in the y values? I'll give you, I don't want to do that. We can't do that symbol anymore. Like 0. There you go. It's 0. Well, look up here. We have this dy dx. And you might recall from, I don't know, pre-cal, that anytime we see the word delta, it means change. Well, that's what's really cool about that Leibniz notation. That d in dy dx stands for delta. So also it stands for change. So when I'm looking for the horizontal, I'm looking for the change in y is 0, or dy is 0. And that's what's really nice about it. Because if you think of your derivative as top and bottom, the dy, the change in y is on top, the change in x is on bottom. I only have to look at the top of my derivative. For same thing for vertical. Can't spell vertical. Vertical. But for vertical, the change in x is 0. So we say dx is 0. So we only have to look at the bottom part of our equation. So when I'm looking for a horizontal tangent, I really only have to look where dy is 0, or the top of my derivative. And the top is just this negative 6x squared equals 0, and x equals 0 right there. Now we are not done because they do say find the points. So for this, remember we have to use the original function, or I should say relationship. Okay, sorry about that. We should use our original relationship. So I'm going to plug it in here. 2 times 0 cubed plus y squared is 3. And I can solve for y. We get plus or minus root 3. So we get 0, root 3, and 0, negative root 3. So we have two places where we have a horizontal tangent, which we could have gotten just by looking at the graph, if you're really good at estimating. Sorry. So How are we doing? Good? All right. So let's try the next one. Now the next one is a favorite of the AP. And it's because of that xy in the middle. Okay? In the middle we have this xy. When we take the derivative, this is a product rule. I promise you're going to see this on quizzes and tests and all sorts of fun stuff. So we have a product rule here. So when I'm taking my derivative, we're going to get that's easy. 2x plus. Anytime I have a product rule, I'm always going to use parentheses. Because if that's a minus, it can really have, if you have a minus there, you're going to have a bad day if you don't have those parentheses. So when I do my product rule, it's the first times the derivative of the second. So we would get x times the derivative of y, which is our new rule today, dy dx, plus the second, which is y, times the derivative of the first, x, which is just 1, minus, let's take the derivative of y cubed. So that becomes 3y squared. But don't forget, it's a chain rule. It's really a chain here. Nobody remembers that, but it is dy dx, and that's going to equal 0 because the derivative of 3 is 0. It's chain rule, but most people just remember, there's a y, I take the derivative. Okay? That's all they do. Solving this one, we get 2x plus x dy dx plus y minus 3y squared dy dx, and that's going to equal 0 for us. I promise you, most of you will be able to go straight from here, straight to your answer. I'm going to show one more step. Because I like to get rid of things that don't belong. So anything that has a dy dx can stay. So I get x dy dx minus 3y squared dy dx, and that's going to equal, everything else goes over, negative 2x minus y. And I know I'm going to factor and divide, so I'm just going to do that all in my head. I get negative 2x minus y divided by x minus 3y squared. And there's our answer right there. Now, other questions we might ask. Where is there a horizontal tangent? Where is there a vertical tangent? So I could easily ask you those on a quiz or a test, or I might just call you randomly tonight and say, "Yo, Tam, find the vertical tangent." I should do that. Since we're asynchronous learning now, I can do that. Who shall be my first victims? All right, so if we take a look here at number 5 right now, this is the one that my ex-girlfriend gave me. Her name was Tanny, by the way. We'll find out. So when we take the derivative here, we should recognize again we have a product rule. When we take the derivative, we're going to take the first function, which is our cosine of x, multiply that by the derivative of sine y, which becomes cosine y. But remember, it has that y, so I multiply that by dy dx. Plus the second function, which is sine y, and I multiply that by the derivative of cosine x. Negative sine x. Now I don't need to put a dy dx here because I'm not, the derivative of sine of x, cosine of x is negative sine of x. You can put the times 1 for the chain rule if you want to. Equals 0. Remember, it's 0 because that's a constant. Be very careful. And now I can solve for dy dx. So we should be able to do this algebraically pretty quickly. I'm going to bring this part over, and that becomes positive sine x sine y divided by cosine x cosine y. And there's my derivative. I'm okay with that. I'll accept that. But my girlfriend says, "You're not done yet." Okay, so we're not done yet. I can go a little bit further because what is sine of x over cosine of x? Just tangent of x. What is sine y over cosine y? Tangent y. Thanks, Tanny. for giving me this problem. All right. So that was her name, Tanny. She wanted me to thank her, I guess. I don't know. All right. So let's go ahead. I'm going to pause here. Go on to the next one if you're done.